Hey guys, this is our next step into trigonometry, and it's all about how to find the side of a triangle. So normally we have two sides of a right triangle, and we use the Pythagorean theorem to solve. In this case, I'm just going to give you an angle and a side, and we're going to have to find another side. So by the end of this video, you're going to know how to do that. So the first thing we need to remember is the stuff from the previous video, where we remember that the sine of any angle is a ratio of the opposite side over the hypotenuse. The cosine of the angle is the ratio between the adjacent side and the hypotenuse. And the tangent of any angle is related to the ratio of the opposite over the adjacent side. So you're going to be given a triangle like this. You have to decide, okay, I'm given this angle. That's my theta. Okay. Then I have these two sides marked. That x is actually the opposite side because it's across from the angle. This 11 is the adjacent side because that's next to the angle. So opposite, adjacent, I'm going to use my tangent function. So I'm going to say, okay, so the tangent of that angle, that's 64, equals my opposite side, my x, over my adjacent side, the 11. Now what I do is I take that tangent and I plug it into my calculator. So I would hit just the tan of 64, and it comes out to be a big long decimal. I'm going to take the first three decimal places. So I'm going to say it's 2.050 equals x over 11. Now, what we've been doing is creating proportions out of that. This doesn't have a fraction. I'm going to put that over 1. I'm always going to put that over 1. Now I can cross multiply. X times 1 is x. 2.050 times 11 is 22.55. That is how long x is. And I just found it. Now the next problem deals with a different type of angle. Now I got 29. Okay. Oh. Side across from the right angle is always the hypotenuse. Okay, and then I have x labeled as the side next to the angle, so that's my adjacent. So I'm going to use my cosine function, because remember, cosine of any angle is my adjacent side over my hypotenuse. So I'm going to plug that in. The cosine of 29 equals my adjacent side over my hypotenuse. Okay, so the cosine of 29 is 0.8746 equals x over 29. Now, put that over 1, cross multiply, x equals 25.36, which makes sense because the hypotenuse has to be bigger than the adjacent side, so I'm good. The other example I'm going to do, 5 I'm not going to do, I'm going to go on to 10 here, because now I have this 63-degree angle, I have the side opposite of it, and I have the hypotenuse, because the hypotenuse is across from the 90-degree angle. So now I'm going to use my sine function. So the sine of theta equals my opposite over hypotenuse. When I plug things in, I'm going to get the sine of 63 equals, now it's going to be 12, because that's my opposite side, over the hypotenuse, which is x. So the first step I do is I find the sine of 63. 0.8910 equals 12 over x. And this is where I added in that 1. because now I have to cross multiply. Now I get 0.8910x equals 12. Now I have to divide by that decimal place. X equals 13.468. Now, X was my hypotenuse. So should it be bigger than 12? Yeah, because it has to be the biggest side. So for the rest of these problems, try them. Set up the trig ratios here. Remember to identify if it's the opposite or the adjacent or the hypotenuse. Come with any questions and check with me when you're done with these practicals.